In this unit, one of the major topics or most important things that we're going to be able to start by figuring out with is determining whether something is an equation or is an expression. An equation, as it states on your paper here, is something that is a statement about equality of two expressions. Basically, to put this as simple as possible, an equation has an equal sign. An equation has an equal sign. Whereas an expression does not. So that's one of the first things that we need to have an understanding about is what makes something an equation versus an expression. The reason this is important because equations can be solved. So if we look at question number 1 or exercise 1, it says which of the following is not an equation? Very simple question. If I look at the 4 choices, choice 1 has an equal sign. So does choice 2. Choice 3 does not have an equal sign. And choice 4 does, so the correct answer is choice 3, 2 parentheses 4x plus 1. This is an example of an expression. In the next part it says here equations can be true, like choice 1 above, or false, like choice 4, depending on whether the two expressions are equal or not equal. So if we look back at choice 1, it says 3 plus 1 equals 4 plus 0. And we know that this is true. Because the truth of the matter is 3 plus 1 equals 4, and 4 plus 0 equals 4, and that makes it true. Choice 4 says 1 plus 3 equals 6. 1 plus 3 is 4. 4 is equal to 6, and that's not true. Or that's false. And one of the ways that we can write not true is an equal to symbol with a line through it. This means not equal. Not equal. Choice 2, we don't know if this is true or false because we don't know what x is. X is an unknown. If you told me x was 2, we could tell that it's false. If we told x was a different number, we could tell whether it's true or false, and that's something we're going to look at very quickly. So in exercise 2 here, it says consider the equation 2x minus 8 equals 10 minus x. Part A says, why can't we determine whether this equation is true or false? And the reason that we have no idea whether this is true or false is we don't know what x is. We have no idea what x is. In letter B, it says if x equals 5, will this equation be true? How can you tell? Now, one way we could tell is the old-fashioned way. By taking our two expressions, 2x minus 8 equals 10 minus x. All I did was I recopied this. Now what I'm going to do is I'm going to replace x with 5. So I'm going to take 2 minus 8 equals 10 minus, and what I'm going to do is they're suggesting x is 5. I'm going to replace x with a 5. When I go through and do this math, what I end up with is 2 times 5 is 10 minus 8 equals 10 minus 5 is 5. Is 10 minus 8 5? And the answer is no. 2 is not equal to 5. This is false, which means x does not equal 5. Another way that we can do this in the easier way, and the way that we're going to do it a lot, is on the calculator. So if we go to your calculators and you turn on the graphing page, what we're going to do is they're asking us to test, is x 5? So we're going to take 5 and we're going to store that for x. And hit enter. And then what we're going to do is we're going to type in our two equations, we're going to type in our equation 2x minus 8 equals 10 minus x. 2x minus 8 equals 10 minus x. We're going to let the calculator do the work for us. No sense in us making a careless mistake. We've told the calculator what we think x is. We're typing in 2x minus 8 equals 10 minus x. We hit enter and it tells us false, which is the exact same thing that we found when we did it by hand. In part C, it says show that x equals 6 makes the equation true. Remember to think very carefully about your order of operations. And we are not going to worry about our order of operations at all. We're going to let the calculator worry about our order of operations. It says show that x equals 6 makes this true. So I'm going to store x, 6 for x. And then I'm going to go through. I'm going to copy and paste what I typed in earlier. 2x minus 8 equals 10 minus x. I'm going to hit enter and it tells me that it's true. So when we store 6 for x and let the calculator evaluate it, it says true. And that's what we're going to do. We're going to let the calculator do a lot of the work for us in this entire unit. A variable, it says in this box down below, a value for a variable is called the solution to the equation if when substituted into both expressions, the result in the equation is being true. That's exactly what we did. So if we store a value for a variable and type in the equation we want to test it for, and it tells us true, it tells us that that is the solution to the equation. On page 2, this is amazingly important. It's so as simple as this is, this concept is going to be key throughout this entire unit. So what's going to become important is how do I type in all these different expressions, or how do I type in the equations using the calculator? The concept is amazingly important. It implies you know how when you've solved the equation correctly. We used to have to do this the old-fashioned way, but we're not going to do that anymore. We're literally going to do exactly what we had said earlier. So it says here in part A, 2x plus 3 equals 17, x equals 7. We're going to test on the calculator if this is true or false. Now I've split my screen here, so it's going to be a little bit difficult to see, but we're going to have to do our best to follow along. But the first thing I need to do in part letter A, it says 2x plus 3 equals 17 when x equals 7. You have to first store 7 for x, and then type in 2x plus 3 equals 17. It tells us true, which tells it that this is a solution. In letter B, they want us to test if x minus 20 divided by 5 is equal to negative 4 when x equals 10. So I'm going to store 10 for x, and I'm going to test if x minus 20 divided by 5 equals negative 4. and it tells me false. Now it's important to point out right now that we know that it says false. So what that tells us is x is not equal to 10. I don't know what x is. We haven't been able to find that out yet. But we know for a fact that right now x equaling 10 is not the right answer. If I go to letter C, it's asking me to figure out if 2 parentheses x plus 5 is equal to 6 parentheses x minus 1 when x equals 4. So again, 4 store x and do 2 parentheses x plus 5 equal to 6 parentheses x minus 1. I checked to make sure that I typed in everything correctly because we're relying on the technology. I hit enter and it tells me true. And what that tells me is if I plugged in a 4x, this would be true. Letter D gets a little bit more complicated. It says x squared minus 1 is equal to 2x plus 2 when x equals negative 1. Remember, the negative or a minus in front of a number tells us that it's a negative number. And I'm literally going to type in x squared minus 1 equals 2x plus 2. Enter. That one is also true. Which means if I plug in a negative 1 to that equation, that it will be, those two quantities are equal. I'm going to leave the last two for you to try right now on your own. As you can see from my calculations, I stored it 2 for x, and I typed in 3 parentheses x plus 2 over 4 minus 1 equals 5. And that told me that letter E was false. And similarly, when I stored 8 for x and typed in the equation they wanted to test me for, letter F became true. So right now what I'm saying, and as this worksheet points out, this is no excuse land. If you solve an equation, you have to be able to check to see if your solution is correct. Sometimes mistakes happen. It's good to be able to spot them. So if we can see here,